Hello friends, welcome back to our channel. In this video, we are going to see how to set up the DNS server and the DNS client in Linux machine with Ubuntu operating system. In the previous video, we have discussed about some of the important concepts of DNS. In that session, we have discussed about different types of DNS servers. For example, authoritative DNS server, DNS resolver, root DNS server, the top level domain or TLD server, and also we have discussed about DNS zones, DNS records and DNS cache. So in this video, we are going to set up two servers, the primary server and the secondary server, and also we are going to create a new zone for the domain myexample.com. So before setting up the zone, we are going to install the DNS server by using the package bind9. After installing the DNS with bind9 package, then we are going to create the DNS zones corresponding to myexample.com. In the secondary server also we are going to install corresponding DNS server by using bind9 package, and then we are going to see how the zones would be transferred from primary server to secondary server. Primary and secondary servers are authoritative name servers for the internal domain myexample.com. That means the zones in these servers will contain all the internal DNS records corresponding to myexample.com. And then we are going to set up the DNS client. We are also going to see how the client sends DNS queries to these DNS servers. There we'll consider two conditions, with DNS resolver and also without DNS resolver. So initially for testing, we are going to see the DNS queries from client to server without DNS resolver. After that, we'll also see with the DNS resolver. We are also going to see how DNS cache will improve the performance of DNS queries. While sending the queries, we'll see the DNS lookups using two important commands, diz or dig and also ns lookup. So finally, we are going to see the concept of DNS forwarders. Using this DNS forwarders, how these primary or secondary DNS servers will forward the DNS requests to other external servers, which will resolve the DNS queries from corresponding root, TLD and external authoritative DNS servers. So these external servers will resolve the queries if the request comes for external domains other than myexample.com. After resolving, they will provide the response to corresponding primary or secondary DNS servers, and then the response will go back to the client. So let us see all these concepts in the demo. Let us start. For the demo, I am using three machines here. These are Ubuntu Linux machines. Let us verify the version of the operating system. Here the version is Ubuntu 24.04. So in all the three machines, I am using the version Ubuntu 24.04. The first two machines, the master and slave one, will be used as the DNS servers like primary server and the secondary server. And the third machine I will use for the client. So this client can be anything. It does not need to contain the operating system Ubuntu 24.04 because that is the client machine. Now let's install the required packages in all these three machines. So in the master and the slave one machines, we'll install the server package and some other utils package as well. So in Ubuntu, for setting up a DNS server, we can use a library called bind9. So let us install the bind9 package in both master as well as slave one. So for this, I'm using apt command. Similarly, I will install the same in slave one as well. In the master, the package is successfully installed. In the slave one also, it is successfully installed. We do not need to install bind package in the client machine because that is not a server machine. Now we will install a package called DNS utils that will have all the required commands to contact the DNS server. So we will install that package in all the three machines. It is installed successfully in master server. Let's perform the same in slave one as well as client. So the package is installed. Now let us perform the required configurations in both of the servers. Now let us see some of the configuration files in the primary server. The configuration files are placed in etc bind directory. So here we can see some of the important configuration files. The main file is name.conf file. So let us try to open this. It says this is the primary configuration file for the bind DNS server named. It is also saying if you are just adding zones please do that in this local file. So that means if we want to add new zones, we need to place them in name.conf.local file. So this file, this name.conf includes this local file. That's why if we put new zones in this file, those will be automatically included. So let us try to open this local file once. So as of now, it does not contain anything. If we want to add new zones, we have to add in this file. We also have other two files. Let us try to check other two files as well. So we have this name.conf.default zones file. This contains the default zones which comes with this configuration. So this is for root zone and this is the corresponding file. And then next it contains the zones for localhost. So the zone name is localhost and this is the corresponding DB file which contains configuration corresponding to this localhost zone. The remaining three are for reverse lookups. In this video we are not going to see the reverse lookups. We only configure the forward lookups. So we need to configure our zone something like this. So let us copy this. So we need to create the zone for our example domain myexample.com. So let me replace this localhost with myexample. So I have replaced with myexample.com. For DB instead of local, I need to put myexample.com. So we need to place this zone configuration in this name.conf.local file. And also we need to have this file. So before creating this file, let's try to check what is there in the db.local file. So this is the zone file content corresponding to localhost. Similarly, we need to prepare the content for myexample.com zone. So let me copy this content. So we need to replace this with myexample.com. So instead of localhost, let us keep myexample.com. Similarly, here also we can put myexample.com. So now let us discuss about this content. Basically, this is a zone file for domain myexample.com. So this TTL indicates time to live. This means how long the data in this zone file will be cached in DNS resolver and so on. This value is in seconds. So this means around 7 days. The next is SOA. The SOA or state of authority. This record contains the admin data for this zone. Here myexample.com. This indicates the primary DNS server for this zone. And this root.myexample.com. So this is the mail ID. Actually this dot in the bind syntax means it's root@myexample.com. And these next parameters will be used by the secondary server. Here the serial indicates the version of this zone file. Every time we change the content, we need to increment this serial so that the secondary server will check this serial. If it is changed, then it will try to refresh the data. So the next is refresh. This means how often the secondary server will refresh the data with the primary server. So here it is around 7 days, but we have to reduce this to refresh the data very often. For example, if the refresh is failed from primary to secondary, the secondary will retry again after this period. So the next is expire. For example, the primary server is not reachable to the secondary server, then the secondary server will hold the data till this time period. That means after this time period, it will discard the data and it will not serve the DNS queries. The next one is native cache TTL. This is the time to live period for the non-existent domains. If the query comes for a domain which is non-existent, then the results will be stored for that non-existent domain till this time period. This will be used to avoid the redundant request to the DNS server for the non-existent domains. So this is about the SOA data. So this is the name server record. So let us change from localhost to myexample.com. This is a name server record. So this record will identify the authoritative name server for this zone. Here myexample.com is the DNS server which hosts this zone file. The next one is a record. So let us change this to IP address of myexample.com. So let us try to check the IP address. So this is the IP address. And the next one is IPv6 address. As of now, I don't have any IPv6, so I will keep it. Otherwise, we have to replace this with the existing IPv6 address. So basically, these two records identify the A records for the domain myexample.com. So if you want to have a record for this name server, again we can keep that. So let us write with semicolon. So this should be like ns dot. So I am mentioning ns here. We are writing a record, so I am keeping a here. And then the IP address of this name server. So this is similar to the domain IP address. So these two are the A records for the domain. So let us write that. This is the main domain. So this is the name server record. So this is the A record corresponding to our name server. So if you want to have any subdomains, for example, we can create corresponding A records here. For example, we have mail.myexample.com. So I need to specify mail here and then we are specifying the A record here. So A, and we have to provide the IP address. So I'm keeping the same IP address here. So if you have like multiple subdomains, we can write subdomains in the same format like this. For example, if we want to write alias record, so we can write, so let us write alias here. For example, we are creating an alias www.myexample.com, which should point to myexample.com. So in that case, we need to place www here. So here IN, and after that, instead of A, we need to specify CNAME. Then we need to specify to which domain we are pointing to, myexample.com. So this way we can create different types of records in the zone file. So let us copy this content in the primary server. In file, etc bind name.conf.local file. So here at the end of this file, I am adding this content. So let us save this file. So the file is saved. Now let us copy this content inside this file. So let's create a file now. So this is the zone file corresponding to myexample.com domain. Let me copy and paste this content there. So let us save this file now. This file is also saved. Now let us restart the bind service to reflect all these changes. So the service is restarted. Let us check the status of the service. It started the named service and it is running. I think this is related to DNS security. As of now, let's ignore this warning. So we have configured the forward lookup zone. That means whenever users will ask for the IP addresses by providing domain name, this server will provide that. But we are not configuring any reverse lookup zones. That means by giving input as IP address, we cannot get the domain name. So that will not be configured in this session. Let's verify whether the config files are correct by using some commands. So let us execute a command called name check conf. It did not print anything. That means the configuration files are correct. We can also verify whether the zone files are correct. For that, we need to use name check zone command. So now we need to provide the zone name, and then we need to provide the zone file. So let's execute this. Here we can see the zone is loaded and it is okay. Here we can also see the version of this zone file, which is 2. So now we have verified the main configuration file as well as the zone files. Both are okay. Now let us configure the secondary server as well. So let me copy this. If you want to transfer the zone file content to secondary servers, we need to add one more tag in the primary configuration file, that is allow transfer. Then we need to provide the IP address of the secondary server to which we want to transfer. Let us check the IP address here. And this is the IP address. So this we need to add in the primary configuration. So I am adding in primary server. So I am adding here. So now let us configure in secondary server. So in secondary server, the type should not be master. So this should be secondary. This will come from the primary. So just give the file name and we need to provide what is the master. So for that we need to specify a tag called masters. Under masters we need to provide the IP address of the master. So this we need to configure in the secondary server. So here we are saying the type is secondary, which indicates it's a secondary server, and this file will be copied from the primary server, and this is the master IP address from which the zone files will be transferred. So this configuration we do not need to do in the secondary server because that will be transferred from primary. So let me delete this. So let us add this in secondary server. So I am adding in name.conf.local. So the content is added. So let us save both the files in primary as well as secondary. The file is saved in both the machines. Now let us restart bind and service in both the machines. So this is restarted in both the VMs. In the secondary server, let us check the status. So here we can see the zone transfer started, and the transfer of zone myexample.com from this is the IP address of the primary server, and 53 is the port for DNS. That means the transfer is started and the zone is transferred, and here it has printed the transfer status as success. So that means the transfer is completed with one message and 8 records. So this is the basic setup of primary and secondary. Now let us configure the client and we'll verify the DNS server lookup by using some Linux commands in the client machine. Before setting up the slave, let us perform one more thing. We need to add the name server corresponding to secondary server in the zone file. So let's do that. So I am opening the zone file in primary server. So here we need to add the name server corresponding to secondary server. So let me change it to NS1. Let me add a new record. So this is our second name server. We also need to add corresponding A record for this name server. Here I am changing NS to NS1. So let's add a new record here. So this is for secondary server. So this record is the A record for the name server NS2, which is our secondary server. In addition to these changes, we also need to change the serial here so that the secondary server will update the config files. So I have changed it to 3. That means the version is changed now. So let's save this file. So the zone file is saved. Now let us restart the bind service. It is restarted. Let's verify the service status in the secondary server. So now we can see the transfer is completed and the version is serial 3. So that means the data transfer has been completed from primary server to secondary server. So now let us start the client configuration. Basically in the client machine, we need to point the name servers as the primary server and secondary server, and we need to have the search domain as myexample.com. This client can be any machine with Ubuntu operating system or CentOS operating system or Windows operating system, as long as the client reaches the server on port 53. If any firewalls need to be opened in the server like port 53, we have to open corresponding port. Here I am using the client with Ubuntu operating system. Here we have already installed a package called DNS Utils. That means we have already some client tools which can send the DNS queries to server. So let us open /etc resolve.conf file. So let us add the name servers now in this file. So this is the IP address of our primary server. So let's add name server secondary for fallback. Now we need to add the search domain, that is myexample.com. For example, if we search any subdomain, for example www, it will be searched in this domain. That means it will be converted as www.myexample.com. So let us save this file. The file is saved. In Ubuntu systems, generally this file is managed by systemd resolved daemon. So the contents of this file will be edited automatically by the daemon. So for our testing, I'll disable that systemd resolved daemon. So I'm stopping that. So this is done for testing only. Now let us use the client tools to send queries to DNS server. Initially I'm using NS lookup. So let me enter this. Now we need to mention what is the DNS server we want to use. I'm using the primary server here. So now this is the default server. Let us send a query for myexample.com. Now we can see the server has responded. This is our authoritative DNS server. And for this domain, it has replied the address as 192.168.56.101. This is as per the A record we configured in the primary server. Let us query for mail. If we provide mail here, it would be searched in mail.myexample.com because we have set the search domain as myexample.com. So let us enter. Now we can see the server has provided the response mail.myexample.com with corresponding IP address. So these are A records. Here we have also configured alias record for www.myexample.com. So let us search for it. Now again the primary server has replied. So this is what we have searched for, www.myexample.com. Now it has provided the response with canonical name myexample.com and corresponding A record for the myexample.com. So this is how we can send queries by using NS lookup. Now let us send the queries to secondary server as well. So for that I'm using server with IP address of second one. So now we have made the default server as secondary server. Again let us send the queries. If I send www, now the second server with this IP address has sent the response and it has sent the CNAME record for this www.myexample.com as myexample.com. It also has sent corresponding A record for myexample.com. Similarly, we can also send mail here. That means mail.myexample.com. We can see corresponding A record. This way we can use both the name servers for responding to the DNS queries sent by clients. So by default, if we send the DNS queries, the primary server will send the responses. If the primary server is not reachable, then the secondary server will respond to the queries. So let us verify that also. So I am sending nslookup myexample.com. So by default the primary server should send the response. So here we can see, so this is the primary server and it has responded with the A record. So now let us stop the primary server. So the primary server is stopped. Now let us see what will happen if we send the query. Here we can see the first server is not reachable. Then the second server has responded with this A records. So let's start the service again. The service is started. So let us check the query again. So now we can see the primary server has provided the DNS response. So this way we can use nslookup command to send the DNS queries to the DNS server. We also have one more important command which is called as dig. So let us use dig command for some of the DNS queries. For requesting A records, we need to provide the domain or subdomain name as a parameter to the dig command. So let us provide myexample.com. So here we can see the answer section which provided the A record for the domain myexample.com. It also displays how much time it has taken for this query, and this is the server. We can also provide the type of records we want to the dig command. For example, if we want to see what are the authoritative servers for the domain myexample.com, then we need to provide the type of record as NS. Let's execute this. Here we can see there are two NS records, ns2.myexample.com and ns1.myexample.com, and these are the corresponding A records of those name servers. So these are the two authoritative servers for this myexample.com domain. We can also mention the name server for which we send the queries. So for that we need to add @ here, for example the IP address. So let's use secondary server now, and then the domain or subdomain. So let us provide mail.myexample.com. Now we can see the second name server or the secondary server is used for sending the response, and also we can see corresponding A record. So far we have seen how to set up the primary and secondary authoritative DNS servers. We have set up the zone and corresponding DNS records for myexample.com domain. We also have seen how to set up the client. So in the client, actually we have bypassed the local DNS resolver or stub resolver for testing these authoritative DNS queries. Till now all the queries are for internal DNS records. Now let us see what will happen if the client sends the DNS queries for external websites or external domains. So in that case, these servers will be used as the DNS resolvers, and then these servers will fetch the DNS response by contacting with other servers like root servers, TLD servers, and corresponding external authoritative DNS servers, and then these servers will provide the response to the client. So during this process, these servers will also cache the DNS results, so that if the client requests the same DNS record, then they will directly provide corresponding DNS record which is in the cache. So let's see this now. Now let us send a query for ubuntu.com. So initially it takes some time for getting the results from the external DNS servers. This is our primary server. So this has got corresponding DNS responses from the name servers responsible for external website ubuntu.com. This query has taken 2230 milliseconds. Now let us query for the same website. So this should take less time because the query needs to use the DNS results which are present in the DNS cache. So let's try that. Now we can see the response time is drastically reduced to 372 milliseconds. This means it is using the results in the DNS cache. So for configuring the DNS cache, we do not need to perform any task. By default, it has the feature of DNS cache. So in this case, this server is used as the DNS resolver. So for external websites, our primary or secondary servers will be used as the DNS resolver, which fetches the results from external DNS servers, and then they will store in cache and provide corresponding response to DNS clients. So one more thing we need to understand that whatever response these servers are providing for external queries are non-authoritative. That means they are not responsible for providing corresponding DNS records to clients directly. So they will get it from other servers and provide those results to clients. Let's see the same by using nslookup command. Here we can see this server has provided the response, but this is non-authoritative. That means the primary server fetched the results from external servers. So far we have disabled the local DNS resolver or the stub resolver to test the DNS queries and corresponding responses. Now let us enable the local DNS resolver. That means the client will send the request to the local DNS resolver which is present in the client machine, and then this resolver will send queries to our primary or DNS servers or external websites based on the domain for which the client sends the request. So in this case, this DNS resolver is responsible for fetching the DNS results, and also this resolver will store corresponding DNS results in DNS cache of this resolver. The main advantage of this is we will reduce the load on primary and secondary servers for external domain requests, because the DNS resolver itself will take care of for those recursive DNS queries. Now let's enable the local DNS resolver and see how to send the queries and get the corresponding responses. So we need to restore the etc resolve.conf file which we have changed earlier. For that, I'll copy the file content from one of the servers. So generally we don't change this file, but for testing the bypassing of the local DNS resolver, we have done the editing of that file. So let's restore it. So I'm deleting these contents and I will insert the same content from one of the servers. So this will be used by the systemd resolved, and here the name server points to which is responsible for resolving the DNS queries in that machine. So let's save this file. So the file is saved. So before restarting the systemd resolver, we also need to enter the primary and secondary DNS servers information to one of the configuration files of systemd resolved. So for that, let's go to etc systemd. So here we can see there is a file resolve.conf. Let us open that. So in this file, we can mention what are all the DNS servers we can use, and also we can have domains here. So that means we have to put myexample.com. We can also point to fallback DNS. That means if our DNS servers does not work, then the request will go to corresponding fallback server. So for this, either we can change this file directly, or it is better to place a drop-in file under this directory. So let us go to this directory and we'll create a new file. So this directory is not present by default. So let's create it. Let us go to the directory. Now we need to create a configuration file in this directory. So let me create some dns.conf. So here we need to enter the details of the primary and secondary DNS servers as well as myexample.com domain. For this, I have already created the content here. So here under resolve, I am putting the DNS servers, the primary, secondary, and this is the DNS resolver which is hosted by google.com. So that means whenever we request for any external websites, the request will go via this DNS resolver and it will take care of fetching the results. And this fallback DNS is hosted by Cloudflare. That means if any of the DNS servers are not working here, the request will go to this server. So here domains will add the suffix for the short queries. For example, if we use www in the query, then it will be converted to www.example.com. So let's paste this content there. Now let us save this file content. The file is saved. Now let us restart the systemd resolve daemon. Now we have done the required configurations to include the local DNS resolver or the stub DNS resolver in the client machine. So now let us send some queries here. Now let us look for myexample.com. Now we can see the server is the local DNS resolver. That means this is giving response to us, and this is a non-authoritative answer because this resolver will contact our primary server to get the A record for myexample.com, and the result will be stored in the cache of this local DNS resolver. Then we are getting the result from it. Similarly, we can send the request for external websites. Let us search for oracle.com. So now we can see the server is the local DNS resolver and we have got the A record for oracle.com. Now let us request via NSLOOKUP. Here also we can see this is the server which is providing the response for us, and also this is non-authoritative answer because this server does not contain these records. It gets from external name servers of oracle.com. This way we can use the local DNS resolver to get the responses of our DNS queries. We have one more topic remaining, which is DNS forwarders. So as of now, we have set up the local DNS to use DNS servers. That means we are sending the request to 8.8.8.8 if you are querying for external websites or external domains. Instead of doing here in the DNS resolver in the client side, if you want to perform the similar thing in our primary or secondary DNS servers, then we can use DNS forwarders. So here we can configure in the primary server the DNS options to forward the request to some external server like 8.8.8.8 or any other server based on our requirements. So in this case, first of all, it will check the queries for the local records. Then the server will directly respond with the corresponding A record or CNAME record and so on. If the request is not for local domain and if the request is for external domain, then it will check in the cache. If it is present in cache, then it will respond with the corresponding record. If it is not present in cache, then it will forward the request to corresponding external server. That means these forwarders can be configured at server level. And here, as previously discussed, and in the DNS resolver, we can configure DNS. If we configure DNS here like this, then the DNS resolver directly will send the request to this server. In that case, this will be ignored. So in the client side, if you configure the DNS server option in the DNS resolver, then it will overwrite corresponding forwarder thing in the server. So if the request goes to forwarders and if the corresponding server is not able to resolve, then this primary server will resolve the required queries to the normal resolution like querying root servers, TLD servers and authoritative name servers and so on. And then it will get the response. Accordingly, it will send it back to client. So if you want to configure in the server level, let's go to etc bind. Here we have a file called name.config.options. So let us open that. So in this file, so here we can add in the forwarder section and then we have to restart corresponding bind service. So in this video, we have seen how to configure the DNS servers and corresponding DNS clients in Linux machine with Ubuntu operating system. As part of this, we have seen how to configure the primary server, secondary server, and we have seen how the DNS cache helps in reducing the DNS query resolution times. And we have seen how to set up a DNS zone for an example domain, myexample.com, and we have configured corresponding DNS records like A records, name server records, CNAME records, and so on. And also we have seen how the zone transfer was done from primary to secondary DNS servers. Finally, we have seen how to set up the client with and without DNS resolvers. We also have seen two important commands, nslookup and dig, while testing the DNS queries and corresponding responses. We also have discussed about the DNS forwarders. I hope this content helps. If you like the content, please like, share and subscribe. Thanks a lot for watching.